I still remember the first preview of server components. I was super skeptical. You couldn't even call a wait in them. They had their own magic syntax for everything. You would have to name the files differently to indicate which components were server and which ones were client. I did not think I'd ever be a fan, especially when they made the changes I asked for and I saw the new magic use server and use client directives that made this behavior all possible. I was scared as hell. I really didn't think it would be for me. And as most of you probably know at this point, I was wrong and ended up really liking server components to the point where I was their main defender. Yet now, for most of the apps that I build and deploy to production, I don't find myself using server components very often. I try to use them for things like making a better shell for my apps, but stuff like T3 chat is basically not using them at all. I'm just shimming React Router in there, which is why I was kind of scared but also excited when I saw this blog post pop up. Are server components actually improving performance at all? Hypothetically, they should be. Server components should be the magic perfect solution where code that doesn't need to be dynamic doesn't get sent to the client at all. We just send them the HTML and deal with everything else on the server side. There's so much that should make server components an incredible experience both for developers and for users. But if the performance numbers aren't there, none of this matters in the end. And I try my hardest to be objective when there is data to point to. And historically, there hasn't been enough for me to really lean into. So I'm really excited to dive into what Nadia wrote here and discuss what the performance of server components actually looks like, and if this was all worth it or if we just went the wrong direction entirely. Despite my love of server components, I'm not actually paid by either the React team or by Vercel, so we need a quick break for today's sponsor. Do you know what's harder than coding with one hand? Finding good coding resources as a developer. It's actually getting incredibly difficult now with all the AI slop all over the web. It would be so nice if you could have good resources from actual experienced real-life developers, not just people cranking out crappy tutorials on YouTube. Thankfully, today's sponsor, Frontend Masters, is here for just that. Tutorials that aren't just going to teach you how to code, but are going to help you level up your skills to become a more senior and more talented overall engineer. And what makes their courses special is the people making them. These aren't made by full-time content creators and DevRels. They're made by experienced engineers working at real companies. People like, I guess Primeagen doesn't really count over at Terminal, but Brian Holt from Databricks, or Richard from Zed.dev. Few people understand compilers quite like Zed does, to say the least. Or like David from Microsoft and XState, who's one of the most talented engineers when it comes to state management work. Scott from Netflix, and so many more. I am regularly surprised when I look through the list of the different courses, just seeing who made them. I'm actually really excited for the JavaScript Hard Parts stream on September 17th. Check it out if you're interested. I'm sure that's going to be really fun. But the value you're getting here is insane. Over 250 courses for a cheap monthly subscription, and your company might even be down to pay. It's already cheap, but if you use my link, you'll get 25% off. That's an insane deal for access to all of these resources. If you want to learn from the best, check them out today at soydev.link/masters. I am so excited to have real data on this. I should have built something like this myself, but I'm busy, to say the least. Have you heard of server components? You probably have. It's everything anyone talks about in the React community in the last few years. It's also the most misunderstood concept. To be totally honest, I didn't get the point for a while either. It's way too conceptual for my practical mind. It is definitely pretty conceptual and high level considering the weeds of inside of components that we normally live in. Even just the fact that server components have to start at the root makes it relatively unintuitive to grasp initially. We could fetch data on the server with Next.js and APIs like get server-side props way before server components were introduced. So what's the difference? Well, server-side props is like the single worst API ever defined. Like it's so funny to me. People are mad about the current APIs. It's like they never touched server-side props. It was the fucking worst in literally every single way. It's a downgrade in every measurable format for what we have now with server components. But yeah. We got to pretend that server-side props doesn't exist to have this conversation, because otherwise I'll just be angry, because I fucking hated that API so much. Oh God, I forgot about get server-side props. I have to use it daily at my Next.12 project. Yeah, fun fact, my blog originally started because I wanted to make fun of how much I hated the AirPod Maxes. But the reason I brought it back and started posting a little bit again before just going out on video was me wanting to bitch about how awful the type safety story was in Next.js. 4 years ago now, which is kind of wild how fast the time has gone. But all of this was me bitching about the misery that was get server-side props. So here I had get server-side props as an example to get data to this component, but we don't know if user exists because we don't know what we're getting back in the component, because it's a magic thing that gets passed down. You can manually type it, so I can define user as user from Prisma client, But what if I only select ID from user or select a different subset? There is no guarantee I'm passing the right data down because this is just two magic things defined in your page. You have your default page function, which is a component, and then you have the get server side function, and there's no relationship between these. I will never for the life of me understand why this is the part that they copied in Remix, because this was bad here, it was worse in Remix. Anyways, but I do not want to just keep complaining about an API that hasn't made sense for 4 years. Nadia here to quite the comparison. She compared how the patterns differ from both the implementation point of view, but also how data is fetched across the different rendering techniques and the performance impact of each of them in different variations, which apparently led to it all finally clicking for her. So hopefully, if you're not at that point where server components have clicked, our read through of this will get all of us there. This is exactly what the article does. It looks into how client-side rendering, server-side rendering, and server components are all implemented, how JS and data travel through the network for each of them, and the performance implications of migrating from client-side rendering to server server components. Because these are all different. People seem to think that SSR and RSCs are the same thing, because they're 3 letters that have server in it that are for React. But RSC is just taking components that render on the client and also rendering them on server. Server components are components that only run on the server. Big difference. And we did a semi-real multi-page app to measure all of this, so it'll be fun. It's available on GitHub in case you want to replicate the experiments yourself. I'm going to assume you've at least heard of initial load, client-side rendering, server-side rendering, the Chrome Performance tab, and how to read it. If you need a refresher, here are some articles. And again, article and author will always be linked in the description. Nadia killed it with this, so definitely give her a follow if you haven't yet. This is a very good post, and authors writing stuff this good deserve some attention. She also has a book on web performance fundamentals that seems really, really good. And judging by what I've seen so far, probably a worthwhile purchase. CJE is one of the most trusted people in my community, says that the advanced React book Nadia did is also really good. And I take his word over mine. I'm sure it's great. All this is linked in the description. Introducing the project to measure. It's an interactive and beautiful website. One of the pages looks like this, has an inbox. Some data on the page is dynamic and fetched via REST endpoints. Namely, items in the sidebar on the left are fetched via /API/sidebar, and the messages on the right are fetched via /API/messages. The sidebar endpoint's quite fast, taking 100 milliseconds to execute. The messages endpoint takes up to 1 second. Someone forgot to optimize the backend. Totally unrealistic. The whole project's available on GitHub if you want to take a look. So let's define what we're measuring. When it comes to perf, there's 1,000,001 things that you can measure. It's impossible to say this website is good or bad perf without defining what exactly we mean by performance, good and bad. Oh God, I love this already. This is a very good article. For this particular experiment, I want to see the difference in loading performance between different rendering and data fetching techniques, including server components. For the purpose of understanding them all, and also answering the question, are server components worth it from a performance perspective? I'm going to use the Performance tab of DevTools for measurement with CPU at 6x slowdown and network slow 4G. You can use Chrome DevTools to arbitrarily slow down your browser, slow down your computer, and your network in particular. But 6x slowdown means a different thing on a different computer, so not always the best way. And the way that they slow down your CPU is not necessarily the best representation of a slow device. If you want to make sure your shit works on slow devices, buy a slow device and test it on it. It's the only way you can know. This all does help a ton, though. I do recommend at least doing these types of tests. She's going to be measuring the LCP, which is the longest contentful paint. How long does it take for the major content, like the core content, to render, even if it's just skeletons? The sidebar items visible, which is when do the things on the sidebar appear? The messages visible, which is when do the messages appear? And then when does the page become interactive? When can you actually click things and do things and expect them to work? These are shown as the LCP, where like the page skeleton exists, but the sidebar and the inbox haven't loaded yet. Then you have the sidebar loaded in, but the inbox still has to load. Then you have the inbox loaded in with the messages. Then the button for toggling light and dark mode becomes interactive because the JS is loaded and is now active. This is an important piece because when that happens, might even change throughout. Oh boy. This is a fun call out. Since in dev, everything's using HTTP 1 servers, the limit for how many things can run in parallel with HTTP 1 is 6. So you'll have things that would have otherwise been batched in prod get chunked out into different loads because you can only load so many things at once. She wanted to make sure she was copying how this would actually work in production with a real CDN. So she tested locally by imitating CDN behaviors using Caddy as a reverse proxy. So let's start with the client-side rendering performance. CSR means that you load the whole script on client, and then the script goes and fetches the data. So here we have the script and the link. So this is where the CSS and JS come from. So you load the HTML, your browser goes and fetches these, Now they exist inside of the context of the browser. Now the JS can execute and do what needs to be done. And until then, you don't see anything. Just transform this empty div into a beautiful page. The browser needs to download and execute the JS files. The files will contain everything that you would write as a React dev. So here you have your React components, you have the layout, sidebar, main content, and then something that will actually mount it to the root element. And until then, it's an empty page. React itself transforms the entry point app component into DOM nodes. Then it finds the empty div by its ID and injects accordingly. So if you look at the performance tab here, you have the HTML, the JavaScript, still an empty screen until the JS runs, then it paints, then it goes and does the fetch calls, and then it renders the rest of the data once it comes in. But notice here, the key is that the HTML loads, you see nothing. The JS loads, you still see nothing. The JS executes, now you see things. The HTML loading and the JS loading is not enough for you to see things. As she says, in real life, this will be much messier because you have multiple JS files, sometimes chained CSS files, and a bunch of other stuff happening in the main section. You record the actual profile for the project, you'll see this. You have the index.js, the vendor.js, radix, editor, date functions, and the CSS all loading, thankfully in parallel, but all things that have to complete loading before you could start seeing any content. Data fetching for the sidebar messages is triggered in the JavaScript itself. You have a use effect where the messages are fetched and then stored. It could be any data fetching framework like Tanstack Query, for example. In this case, here we are, Tanstack Query. Nice to see. Doesn't really matter what's important here for the data fetching process to trigger. The JS first needs to be downloaded, compiled, and executed. So no data is being fetched at all until all of those things happen first. That's the key thing to understand with SPAs. You need the page to load, trigger the load for the JavaScript. You need the JavaScript to load, execute, then figure out what data it needs to fetch. And after all of that is done, you then finally start fetching data, which is why when you don't have that JavaScript cached, it can take up to 4.1 seconds to get that first paint because it takes so much time on this fake slow device and slow connection to get all the JavaScript to do that. So you're waiting for 4.1 seconds to see anything on the screen. This is why people don't like client-side rendering. That is really bad. That's enough time for someone to think your website's broken. Aside from everything related to the nice dev experience and learning curve, which are huge deals by themselves, there are two main benefits to SPAs compared to more traditional websites. Because obviously this is bad. So why would we ever do this? Because of the dev experience, learning curves, and a few other things. First thing is performance. Transitions between pages when everything's on the client and there's no back and forth with the server can be incredibly fast. This is why we went single page app for T3 chat, because we wanted it to be as fast as possible when you click around. When I click other projects, I'm clicking now. As soon as I click, my other chats appear because I preload all of the data. And when you click, I'm just changing out what data is rendered in JavaScript. Nothing is loading when you navigate. Yeah, in her example, navigating between pages takes only 80 milliseconds. It's as close to instantaneous as it can get. The other important piece is that it's cheap, ridiculously cheap. You can implement a really complicated, highly interactive, rich experience, upload it to something like the Cloudflare CDN, have millions of monthly users, and still stay on the free plan. Perfect for hobby projects, student projects, and anything with a large potential audience where money is a significant factor. Depends on what the APIs being called are, to be fair. I still don't think the argument in cost is the real reason that server-side rendering matters. I have an article about this on my blog I never talk about. SSR isn't that expensive. It's really not. This started with me bitching on Twitter because I was so annoyed at people having this misconception, but SSR is not that expensive. If you game it to be a really slow render, it can be not free, but it's effectively free. It's so cheap. With a SPA, there's no servers, no maintenance, no CPU or memory monitoring, no scalability issues. So what's not to love? If you need data from a server, you will still have these things. It's just that you're not also rendering React on that server. And those 4-second load times aren't as bad as they look. It only happens the very first time a user visits, but it also happens whenever you push new code up. Granted, for your landing page, it's unacceptable, but for your software as a service project, where you expect users to visit the website often, 4 seconds will only happen once per deploy. Then the JS is downloaded and cached by the browser. Second and following loading numbers will be significantly reduced. Once the JS is in the browser cache, it's only 800 milliseconds for the LCP now. Final number I'm interested in today is when does the toggle become interactive? In this case, since everything shows up only when the JS is executed, it will match the LCP time. So as soon as you see the content, you can click the content. Important distinction. The same time the browser's showing you this UI, the UI is working because the code that shows the UI is the same code that does what the UI does. So now let's compare with server-side rendering. No data fetching. The fact that we have to stare at a blank page for so long started to annoy people, even if it was for the first time only. Plus, for SEO purposes, it wasn't the best solution. This is because you do SEO by putting things in the head tag that describe the page, and also occasionally content on the page that is being scraped by Google and whatnot. But if the content isn't there until you load JavaScript, execute this JavaScript, and fill the page, a scraper can't find that unless it's running a full virtual browser to execute the JavaScript and populate the page, which is so much work that most search engines don't bother, or they put less effort into the pages that require that. People started scratching their heads to come up with a solution to how slow SPAs were, while still staying within React ideally, because that's just too convenient. No one wants to give it up. We know the entire React app at the very end looks something like this. DOM elements, render to DOM app. But what if instead you rendered it to string, and then you have this HTML string that you can send down? Like the actual string that the server can then send to the browser instead of an empty div. So instead of one empty div that's root ID is app, now you just pass the right content down. So you can do very simple client-side rendering where you render the app to string, and then you send that down, and then the HTML has the JS tag so it can take over on the client right after. Just needs one additional step. Find and replace a string in the HTML variable. Inject it in the server response. HTML with SSR, you replace the root with this HTML string, and then you send it down. This is a basic functioning server rendering thing. Funny enough, I wrote very similar code when I was doing my benchmarking of Cloudflare recently. Now the entire UI is visible right at the beginning without waiting for any JS. And this is server-side rendering as well as static site generation, because render to strings an actual real API supported by React. It's the core implementation behind most of the SSR and SSG frameworks. And also my benchmark. A lot of people don't know this. There's an API in React where you can pass it a component, call render to string with a component, and it will respond with the HTML for what it would have rendered. If you do this for her existing client rendered project, it will become a server-side rendered project. The performance will shift slightly. The LCP number will move to the left right after the HTML and CSS are downloaded, since the entire HTML is sent in the initial server response, and everything's visible right away. So this is the key. HTML gets sent down. It won't look quite right because the CSS hasn't loaded yet, but you don't have to wait for all the JS to load. You just have to wait for the CSS to load. And if you want, you can inline the CSS in the HTML. You could even bundle it in via some fun plugins for Next.js. And now, once the whole HTML is loaded, everything is visible. Nothing works yet, but it's all visible. So first, you'll see that the LCP number where the page skeleton's visible should be drastically improved. But you'll still need to download, compile, and execute the same JS in exactly the same way because the page is supposed to be interactive. So again, you have to load all the same JS. You're just getting a better HTML. The only difference between SSR and CSR, if you just turn on SSR for a project, is whatever the initial state the JS would render is sent down by default. So the HTML is sent down with the empty LCP state, and then the JS has to spin up, do all of the same work it would have otherwise, and then all the content comes in. So you're just moving the LCP down. You're not going to change anything else. And while you're waiting for all of that, the page is visible. The gap between the page being visible and waiting for the JS to load to be interactive is the time where the page will appear broken. Most frameworks will now cache events. Like if you click a thing, but the JS isn't loaded, there's like a really small inline bit of JS that will cache the things you did. And once the JS is loaded, we'll replay those events. So usually you won't even feel this. That said, there are other frameworks that are built around their hatred of this desynchronization state where there's UI you could see but can't use yet. This was Quick's whole thing, if you're familiar with Quick. If you're not, no need to familiarize yourself at this point. This is why the time to interactive is so interesting, because during this time, the toggle in the header won't work. If you implement server-side rendering this way, where you're not building a queue system or using a framework that has this working already, that broken window is going to suck because those are clicks that effectively disappear because there's nothing there to keep them. But most modern frameworks have solved this problem. And also, only the LCP mark has moved because the JS still has to load, execute, and then start fetching. The data fetching doesn't happen any sooner with this pattern. So the server-side rendered version has successfully knocked down the time for like a page that's visible by like over 2x. But every other number is effectively exactly the same. So what if we do some server-side data fetching too? Because remember, the data is not being loaded. That happens after. If we want to do the data fetching on the server, we can. So here we fetch the sidebar promise data, we get the message promise data, and then we pass those down and render the app with that data already loaded, so we don't have to call React Query anymore. And we rendered a string, we pass the messages and the sidebar content that we loaded here. Again, she's not using a framework like Next. She's doing this as just serve functions that you could put in Express, which is really cool because it's showing like the concepts deeper. We have a layout, sidebar, main content all being passed from here. But we also need hydration to work. So we need these components to have the data when the JavaScript loads on the client too. So the solution there is either you make them refetch it, or the easiest thing is you pass it as window data inlined in the HTML. And then on client side, you check as window defined. If it isn't, you use what app was passed. And if it is, then you use the value on the window that we assigned. This seems like a hack. And I hate that I talk about get server-side props again, but that's how it worked. We're just binding weird globals to the window. It's not as hacky as it seems, or it is, but it's how we all did it. And now the page structure changes again. We have the HTML, the JS loads, then the JS runs, and the page is interactive. But when the page loads, all the content's already there. But that adds new problems. So here we see it takes 2.1 seconds for the page to get LCP, but you have the sidebar and messages all already working by the time that hits. So you have the full page content ready to go almost immediately. But it actually takes longer for the content to be interactive because in the time you're waiting for that data to fetch, you have no HTML. If the server is doing those data fetches, the ones that are here, effectively we've taken these two fetch calls and put them before the HTML loads. So the HTML hasn't finished loading yet, so there's no way for the browser to start fetching the JavaScript yet. So you're now blocking the JavaScript on the API calls, which means that the time till you can interact has gotten worse. And you're staring at a blank page for longer because you're waiting for all of that to come in before you see anything. The benefit of this is that there's no loading states. You just go from browser blank page load to content already there. But this comes at the cost of now you are delaying how long till users can click because you pushed these API calls ahead of the HTML. The LCP degraded compared to the previous solution because we're blocking the response on the data fetches. So how does the Next.js pages implementation work? So this is the old school get server-side props solution. Get server-side props, we fetch this data, we return it. It's doing basically the exact same thing she did, so it shouldn't be that different. Yeah, client-side data fetching is pretty much the same as the server-side rendering DIY solution she did. Less time to interactive, because I'm sure that Next is doing some better things for that. And the server-side data fetching still makes the time to LCP worse, but everything else stays pretty flat from there. The interaction time is 3.5 seconds, which is still better than the non-Next solutions. Like when people say use a framework, this is what they mean. You can bitch all you want about Next performance, but in a real world-ish scenario, it's still performing significantly better than the vanilla solution. So if you look at my benchmark where I compare the raw throughput for SSR on Next.js versus vanilla React, it makes Next.js look like a terrible choice. But when you're looking at how this impacts actual client-side behaviors, you'll see why Next.js exists. It's doing a lot of other things to make the performance better for users. Yeah, the LCP is slightly worse for the custom implementation. Sidebar messages, on the other hand, show up a second earlier in this case. It's a very visible use case of what will happen when code splitting is performed differently. Next splits the JS into many more chunks than the custom solutions, so they can all load in parallel, which helps a lot with fetching multiple things at once. But those parallel files steal some of the bandwidth from the CSS, so the CSS download takes longer than it would have otherwise. Interesting point. But having them all in parallel makes it faster to download JS overall, which helps with the interactivity gap. Makes sense. And now, for the reason we're all here, server components. Very curious to see how this part does. Because ideally, it should be the best of both, where you have an HTML file that has enough data in it to do an LCP and start fetching the JavaScript, while also in parallel fetching the data from the APIs. The biggest issue with SSR is the no interactivity gap, when the page is already visible, but the JS is still downloading and initializing. That's not the biggest issue. The biggest issue with SSR is that you can't be doing things in parallel. You're effectively choosing between three options. Okay. So there's three things that we have to do. We have to send HTML to client, we have to load JS, and we have to fetch data. In CSR and SSR, these things all block each other. We're effectively changing the order things happen. With client-side rendering, you first send HTML that is empty to the client. So it has nothing but the head tags to fetch JavaScript. You might have a hard-coded skeleton, but for the sake of a basic CSR. We're sending an empty div and a bunch of links to data to go fetch. Then we load the JS that is indicated in that HTML in the header, or in the head tag, not the header, same difference. Then once the JS loads, the JS has to be parsed and run. And then finally we can start fetching data. And the key is that you don't see the UI until here. You don't see anything until this point. So you're just looking at an empty page until then, or a skeleton if you hardcode one, but you don't. You're not looking at anything until then. And each of these has to happen 1, then 2, then 3, then 4. They all block each other. With server-side rendering without data, so we're not data fetching on the server side, we first generate or serve a cached version of the HTML. So the HTML with skeleton is sent. Ideally, you're getting this from a cache, but you might not be. So we'll assume, whatever, we'll just assume it's coming from a cache. Now you can see the content, but everything else is still the same from there. You have to load the JS, parse the JS, then start fetching data. What we've done here is change when you start to see the page looking how you expect, but everything is still blocking. Server-side rendering with data is where things start to get more different though. So server fetches data to HTML sent to client. Now you can see, but considering the fact that the data fetch is the thing that takes multiple seconds, now you're not seeing anything until that's done. So it's actually the longest time till you see anything, but then there's no loading state. You see everything immediately, but it's not interactive yet. The JS still has to load and then parse JS and make page interactive. So now you see better content. So I also want to make this a full line because you're seeing the full content. You just can't interact yet. The problem here is that you can't do these things in parallel. In an ideal world, you'd be able to fetch the data at the same time you're sending HTML to the user, and then they're loading JS while you're still fetching the data. I don't want this to be 1, 2, 3, 4 anymore. Like if we make this blocks, we have HTML, we have load JS, we have run JS, a bit smaller, and then we have the data fetch, which is the longest part. So all we've been doing this whole time is changing the order that things happen. In the standard SSR, we are just improving the quality of the HTML that comes down. Maybe we increase how long it takes for the HTML to come down, but you're just getting better HTML. That's all CSR versus SSR is by default. SSR with data fetching is reordering things a bit. So CSR, SSR, then SSR with data. The difference here is that fetch data gets moved up. So now you get a complete page sooner in terms of what it looks like, but you're not meaningfully decreasing the amount of time it takes for everything to happen. We're just shifting around what is where. If RSCs are what they're promising, what it should be doing is this. So let's see how the results come out. Introducing RSCs. To recap previous sections, fetching and pre-rendering on the server can be really good for the initial load performance numbers, but there are issues. She cites the no interactivity thing here. That's why I just broke off. Because like that's a problem, but in my opinion, the problem is that we're not parallelizing anything. Oh, look, the second issue is data fetching. I want to prefetch messages on the server, thus reducing the time to wait for the messages to appear. It will negatively affect the initial load and the time where the sidebar items show up. Because what's happening here is since we are waiting to load the JS until the data is fetched on the server, it takes longer until you can click because we're not loading the JS as early as we were before. So this ends up making it take longer till the page is interactive, which sucks. We wait for the data first, then we pass the data to render to string, then we send the results to the client. What if our server could be smarter? Those fetch requests are promises. They're async functions. We don't need to wait for them to start doing something. What if we could trigger those fetches, start rendering React stuff immediately, send down something to client? When the sidebar promise is resolved and the data is available, render the sidebar portion, inject it into the server page, and then send that to the client, and do the same for messages. We're replicating the exact same structure of data fetching that we had in client-side rendering before, but on the server. In theory, if this is possible, it could be crazy fast. We'd be able to serve the initial rendered page with placeholders at the speed of the simplest SSR, and still be able to see the sidebar and message items way before any of the JS is downloaded and executed. So to do this, we have to understand server components. Typical React component quite often just lays out HTML tags on a page, like the sidebar component here. There's a bunch of divs and links. It's all still JS. Exactly this code is included in all the JS files that contribute to the no interactivity gap. But there's no interactivity here. It's just the HTML. Like, we don't need to send this as JS. We can send less JavaScript, ideally, if it's something that doesn't change. A good example of this is like a terms of service or a like terms and conditions page, because those are just a bunch of text. You don't have to be able to click the div. So you don't need to send that as JS. The only reason this code is included in the JS bundle is because React needs it to construct the virtual DOM, because React needs to know where everything is on the page to change anything on it. But ideally, we wouldn't have to send this as JS. In the current SSR implementation, whether it's Next page or her custom hacky solution, the process of extracting the tree for the React components happens twice. The first time when you do the pre-render on the server, and the second time from scratch on the client side. Because when you do server-side rendering, the client and the server both have to run the same JavaScript code and come to the same HTML so it can all link together and provide you the experience you expect. And that's hydration, if you're curious. What if we preserve the tree regenerated on the server and just sent it to the client, so React doesn't need to recreate the whole thing and just recreates the parts that are client-side? We could send less JS, reducing the size of the bundle. We wouldn't have to iteratively call all of those things in order to create the whole tree. So how do we send this data? You hack it into the window. And this is actually what happens in most RSC implementations. She migrated to app router, and sure as hell, this is what she saw. __ next _ f dot push all of the data for this tree. It's a modified but recognizable tree of objects that represents what should be rendered on the page. This also does mean you're sending the data twice. You're sending it as HTML, and you're sending it in this embedded JavaScript tag. And when people say that server components don't need a server, this is what they mean. You can, at build time, generate the HTML that isn't going to be dynamic and have a bunch of different HTML pages that have this embedded in the script tag in the page, so you don't have to load JavaScript that isn't used. You can have JavaScript in a React project that is client only, that at build time generates different HTML for different routes, and then just never has to run on a server. It's just not running those components. Part of why I think the server component name is bad, part of why the rollout was bad. Server components should be really good. There are a lot of reasons they're not. This concept, people not getting it, is part of it. With a server component, all that you're sending to the client is the HTML and that weird structure that we just showed. One of the advertised benefits you'll see that go together with server components is a reduction in bundle size. In theory, if all the code and libraries stay on the server and only the final structure sent to the client, the amount of JS downloaded should noticeably decrease. We know the impact of too much JS. This sounds like a good idea. Let's see how it works out. There's also async components. One of the cool parts of server components. You can have a component that fetches data, and you can suspend above, which enables streaming. In a normal SSR implementation, the server will generate the entirety of the HTML and then send it all at once when it's ready. But with streaming, you can first create a node stream and send the pipeable stream data down, so it sends it chunk by chunk as it's ready. What it does is it sends the majority of the page, and then as you finish, it appends new elements to the end with script tags that move them to the right place. It's actually really cool how it works. You don't need to know the details. What you need to know is your components effectively can pop in when they're ready from the same server call. The chunk boundaries for this process are not React components or async components, by the way. It's components that are wrapped in suspense. Remember this, it's crucial. We'll see significant changes when we start measuring. The working implementation of this for a multi-page app like her is insane. Docs don't cover it well. I spent an embarrassing number of hours trying to make it work, and the end result would have been multiple really complicated files and still half broken. It's not a simple render to string like it was with the normal SSR. Yeah, doing this DIY and not doing it via a framework sucks, because that interop between the server and client is non-trivial, and some of the hacks that have been discovered to make it possible are... There's a reason that there's only 2 server component frameworks that are viable. It's not easy to implement, but when you use App Router, it gets a lot easier. And as she says here, Next.js App Router is basically a synonym for server components and streaming at the moment. Yeah, I wish this wasn't the case. I really do. But it is. It's really hard to use it. Server components now are experimentally supported in React Router, which is cool, but Next is still how you're using it almost always. So let's measure App Router after the lift and shift migration. She points out the fact that Next.js has a ton of other things like optimizations, caching assumptions, transformations that will make this not a viable test. So if she just rewrites over, it won't be a fair comparison because there's no way to distinguish between Next.js benefits versus server component benefits. But if she migrates to Pages first, then it's possible to compare between the Pages version that is doing server-side rendering and the App Router version that's doing RSC stuff. She already has the existing version with Pages and client-side data fetching. This is the app with the smallest LCP so far, the second row in the table. Migrate that to the new framework with a completely new mental model, completely new way to fetch data. Let's see. Lift and shift as much as possible. Make sure the app works and nothing is broken. In the context of this experiment, it means re-implementing routing a bit and using use client in every entry file. This will force app router into client components everywhere. So isolate the effects of the new framework. Every benefit or degradation here will be because of the framework, not because of server components or streaming. So this is without server components, just moving everything over to app router. She saw a meaningful improvement from the pages implementation, 1.76 seconds to 1.28 seconds. Although it looks like the sidebar took longer to load from 3.7 to 4.4, 4.2 to 4.9 for the main content. Interesting that LCP got much better. Everything else got worse. Yeah, 500 milliseconds better for LCP, 700 milliseconds worse everywhere else. Very interesting. Apparently, app router delays all JS until after CSS is loaded. The pages version didn't do that and would load them in parallel. As a result, the JavaScript loading stole a bit of bandwidth, and the CSS was loading slower in pages, thus delaying the LCP. That's actually a really cool detail I did not know. I get why they would do it in order to keep like weird edge cases with layout shift from happening. That's very interesting. Also, app router is very busy on the main thread, at least 100 milliseconds worth of tasks more than pages was, because app router does a lot more stuff on the client side. Yeah. In total, the effect I'd say is a bit meh. Maybe further refactoring would make it better. Not much she could do on her side other than maybe inlining the CSS because she's using Tailwind anyways. There's a flag for that, which would keep the CSS from blocking, which could help here. Yeah, even CJE didn't know this. That's how you know we're deep. It's really nice to see people who don't necessarily know all of the history of why all of these things happened on the React and Next teams, but do know how to profile things really well, because she's finding things I wouldn't have because I'm too in the weeds of how these things were all implemented to think about this level of it. There's an XKCD on this. Silicate chemistry is second nature to us geochemists, so it's easy to forget average people probably only know the formula for olivine and 1 or 2 feldspars. And quartz, of course. Yeah, I don't know what people don't know in this world. So I'm too deep. But it's nice seeing that, like, because she doesn't know about the inline the CSS feature in this, she's finding things I wouldn't have found. But now we can compare with the server component implementation when we start removing the use clients in certain places. The JS was reduced all right. On some pages, it was just a little bit, so homepage only took a 2%, but others, by a lot. Login page went to almost 0 from kilobyte values to bytes. But most of the shared chunks didn't change at all, and the performance impact on all the metrics that are important to her on the inbox page were exactly 0. So server components by themselves, without rewritten data fetching in my app, didn't have any performance impact. And I suspect in most real-world messy apps, where use client is slapped randomly here and there without much overthinking, and eventually bubbling up to the very root of most pages, it'll be the same. Yeah, I think that's fair. What happens once you change the data fetching a bit? Instead of use affecting the data on client, you have an async sidebar component that waits for data, parses it, and then renders accordingly. The complicated part here is that when you do this, the sidebar component can't have a parent that's a client component that mounts it. Like, sidebar can't be called from a client component. The root has to be server components, and then up to where this is rendered, it has to be. If you have client components between, you can render them, but you have to pass sidebar as a prop to those, or as a child to those other things. Once you did it, let's see the results. Oof. 1.78 seconds for LCP. That's a little scary that it got worse for that. It shouldn't, theoretically. But it stays at 1.78 for showing all of the content here. Did she not do suspense for this one? Ah, she didn't. Yep, called it. So what happened here is she's fetching the data and it blocks the page load, so nothing gets to client until the data's fetched. But you can wrap components with suspense and show a loading state. This is the one I care about. There we go. 1.28 seconds for LCP, 1.28 seconds for the sidebar, because the sidebar loads fast enough it gets streamed in almost immediately. Wait, why is messages 1.28 as well? That should not have happened. I'm not sure about her LCP measurement here. I might have to run this myself. Interesting. It's so fast that all the numbers merge together again. Something somewhere does some form of batching, I'd assume, and those 3 ended up in the same chunk. But what she did is she increased the load time to be 3 seconds for the sidebar and 5 seconds for messages, so that it will increase how long the whole thing takes, which makes the benefits much more visible here, where you could see we got to start loading the CSS and then the JS way earlier, but the HTML keeps loading because it's still sending data when it's ready. But with traditional SSR, you have to wait for the page to load, then all this stuff happens, but the HTML is not sending anything more. So what's the TLDR here? Client-side rendering is the worst from an initial load point of view, as expected, but once the page is interactive as soon as it appears, and transitions between pages are fast. Server-side rendering can vastly improve load numbers, but it comes at the cost of the no interactivity gap, and also skeletons become a harder problem to solve there. You're stuck waiting on browser load states much more so. I think client-side with skeleton is more ideal than traditional SSR in most cases. Fetching data on the server will slow the initial load, but will also make full-page experience visible much earlier. Priority from traditional SSR to server components with streaming, namely from pages router to app router, can make performance worse if you're not careful. You need to rewrite data fetching to be from the server, and don't forget suspense boundaries to see any improvements. This is a significant dev effort, and it could require re-architecture of your entire app. Migrating from pages to app router can make no interactivity gaps worse because of the delayed JS download, but that might be browser dependent, and also you can preload the CSS. Server components alone don't improve performance if the app's a mix of client and server components. They don't reduce bundle size enough to have any measurable performance impact. Streaming and suspense are what matter. The main performance benefit come from completely rewriting data fetching to be server components first. Yep. Realistically speaking, if you're happy with the way your routing is working and you don't have any interest or plans to move data fetching to server, you probably shouldn't make the move yet. Where server components get really cool is when you are putting some effort into thinking through what components are server, what components are client, and what ones will be streamed in when they're ready. Chat's been calling out that she didn't mention partial pre-rendering at all. The way that she was testing PPR doesn't really matter. What partial pre-rendering is when you generate the HTML here during this step on server, PPR is caching that result and putting it on a CDN so that you don't have to wait for a server to send the response. But since she's doing a fake local reverse proxy anyways, that's going to respond almost immediately. The benefit of taking that chunk and putting it on a CDN is near zero. So not having partial pre-rendering here doesn't matter for the way she's benchmarking. So I don't know why everybody's saying that. Meh. Next 16 also preloads the cached bit, which removes the network hop cost. I'm not sure. Oh, so on the server side, it skips steps because it has that cached part of the tree. I'm not sure I follow. Oh yeah, this is for navigation. So I don't think any of these measurements were navigation though. So the thing that Naman just said, which is actually a really cool benefit, basically partial pre-rendering, it renders until the first await or the first time you call something that's user specific, like you check their headers or whatnot. So it goes down your React tree until you hit an await, and then it caches everything until then, throws it in a CDN, and now you can load that without the server having to load. But more importantly, you can prefetch that for all of the links that are currently available on the page. So when you click one, it can have that partial pre-render, that piece, ready to go when you click. So you see that immediately, and then the rest of the data starts streaming once the server spins up, connects, and sends you that data, which is cool, but that's not what was being tested here. It is a really cool benefit, and it gives you that same feeling that was being described earlier with client side, where when you click something, it changes immediately. What are you saying, Wendro? Next.js pages router with client-side fetching is the best performance overall? No, it doesn't. Looking at the same numbers, pages router with client data fetching does not have the best numbers. Takes 4.2 seconds before you see messages. Also, do you see how short these times get once things are cached? It gets fucking free with app router, with server-side stuff. It has the best time to interactive with data fetching without caching if you ignore the fact that a bunch of the content is still missing. But it has worse time to interactive as soon as you consider that JS might be cached and that you're interacting with content that has to appear still. There is no world in which, when implemented correctly, pages router is better than app router. It just isn't. So I'm could you click the toggle really, really quickly, milliseconds faster when you're still waiting for content that would have been loaded in the app router version? Maybe. But that's purely because of the way the CSS is loading in. That's not a real problem. You lose bandwidth for fetching the unneeded pages though, right? Yes, but almost none. And it doesn't do that until everything else is loaded, which is fine. I think it's great that modern frameworks will prefetch things so that when you click them, it feels faster. No one is getting billed because they loaded another 500 kilobytes of HTML that makes navigating feel better. I think that's fine, as long as it's not blocking other data fetches from happening that are more important. Overall, this is really, really good, though. Thank you again to Nadia for writing this. This is a fantastic write-up. One of the best, first principles, making sure you understand the concepts and you're testing the right things and doing the due diligence to test the actual pieces that matter throughout it. I've never seen someone do a breakdown of these different methods and what the performance actually looks like, while also educating the reader as to how these things differ. This whole thing was great, and the only missing details are actually part of what makes it so good, because all of those are just in the weeds shit that only matter if you care too much like I do. And even then, she gave me a great opportunity to talk more about it. Once again, I highly recommend her work. If you want to learn more about these things, advanced React, web performance fundamentals, and more, check out her work. It's all linked in the description for a reason. She's good at what she does. Thank you all as always. Hope you learned something. And until next time, keep server rendering.